So last time we talked about approximating the area under a curve using shapes that we knew and kind of getting to a point where we had an infinite number of those shapes to get a very, very close approximation. So that was a groundwork, and then it should be relatively simple for this video because we're going to talk about using definite integrals, how to get their value, and how to use them to find the exact area under a curve. First, I'd like to compare what we already know, the indefinite integral, to the definite integral. So looking at our indefinite integral, we see the difference, the main difference in just the question, other than the size of the brackets, is that we don't have the bounds that we get on the definite integral. And we know from last time, or from our indefinite integral study, that if you were to find the answer to this question, to evaluate it, you would end up with x cubed over 9 plus 4x plus c by using that general power rule. Now, that's an expression, but if you do a definite integral, you're going to get a number. Your answer will be a value. So just knowing that is important. So here's how you go about figuring what value the definite integral has. So let's see, we have a continuous function, and that's important. You can't have any discontinuities, you can't have any jumps, you can't have any asymptotes. The interval that you're looking at has to be continuous. The line is never broken. Interval notation, we have a square bracket. Those are two x's, so it's really kind of like x1 and x2, not a coordinate point xy versus xy, which is a point. Okay, so just knowing that. So I'm looking at the interval a to b. So a will always be the lower x value. It will be your leftmost thing. So we could have an interval that we would look at where we could make a -4. And then we could evaluate what's going on or find the value of the definite integral to b. But a must always be on the left and b will be on the right. And likewise, when you do the math, your a value goes on the bottom of the integral sign and your b value goes on the top. This is familiar. Here's our integrand with respect to x, but how we actually do the math is we take the antiderivative at b and we subtract the antiderivative at a. So we just find the antiderivative by integrating and then figure out, so let's say for this one we'd end up doing f of 4, because that's b, capital F of 4, minus the antiderivative at -4. And whatever value that gives us, it'll be this exact area under the curve between the graph, or the line of the function, and the x-axis. So we're going to go back to that equation that we have been using all along and set it up as a definite integral, because we were talking about going from x equals 1 to x equals 5 and using Riemann sums or trapezoid rule to kind of figure out or approximate that area, but now we can find exactly what it is. So we are going from 1 to 5, those are our bounds, and our function is 1 over 3 x squared plus 4 with respect to x. And so what we have to do is we find the antiderivative first, and we've already done this too, and we see that it was, using the power rule, x cubed over 9 plus 4x. If you don't know what I'm doing here, go back to another video. And all we're going to do is basically take f of the upper bound, 5, at b, and the math just goes in. Sorry, I'm jumping ahead and doing the expansion. The math is just 5 cubed over 9 plus 4 times 5, which is 20. And if you're going to be using your fraction to get a really exact answer, 125 over 9. 20, if you do it over 9, will be 180 over 9, which is going to give me 305 over 9. And if I go back and find the antiderivative at 1, f of 1 is going to be 1 cubed over 9 plus 4 times 1. A little more simple, and it's going to be 37 over 9. So our final value will be 305 over 9, the antiderivative at 5, at x equals 5, minus 37 over 9, the antiderivative at x equals 1, and we'll get a final value of 268 over 9, which is approximately equal to 29.78. So there it is. I know at one time with our Riemann sums, I think we'd estimated 26. We had estimated with the right-hand ones 34. With the trapezoid rule, we had estimated 29.99. But the actual area under this curve, this area here, is 268 sorry, over 9. So really, here's the two types of questions you can get. One's asking for the value of the definite integral. One's asking for the exact area under a curve over an interval. Same thing. So when we look at number 1, first thing, find your antiderivative. X squared goes up to x cubed over 3, and the 3 goes up to 3x. Find the value of your antiderivative at the upper bound, capital F of 8. And just kind of moving ahead, if you were to cube 8, you would get 512, and you would have to add 24, 8 times 3, and you're going to get 584 over 3. You find the antiderivative at your lower bound when x is equal to 4. And if you cube 4, you get 64 over 3 plus 3 times 4 is 12. And if you do your fraction math, you get 100 over 3. So your answer is going to be 584 over 3 minus 100 over 3 equals 484 over 3. That is the area under this graph, or the definite integral. Number 2, they're asking kind of the same thing. They're just phrasing it differently. I'll switch to green. So the interval we're interested in is here to here. So when we solve this, we will get this particular area. Okay, so maybe I'll make the question. So notice that my lower bound is -1 and my upper bound is 0. So making sure you put things in the right location. The way we do our questions in this class, we always have an area under a curve. Like we always have our graph will always be in the positive y. So our areas will always be positive. So if you do the math and you get a negative area, you might have just flipped your bounds. Like you might have put -1 on the top and 0 on the bottom, and that changes things. Okay, so the question we're asking you to do here, the interval's in, the function is going in right now, and with respect to x. So we go first and we find the antiderivative. And when you do that math, you're going to -3 stays, x goes up to the power of 5, and we divide by 5. Minus 7x squared over 2 plus 1. Oh, careful. Integral of 1 is x. Okay, so first things first, the upper bound is 0. Well, it's nice. All of these are going to have a 0 in them, so f of 0 will be 0. The lower bound, f of -1, is going to be equal to positive 3/5, watch your signs, minus 7 over 2, minus 1, and maybe for this one I'll work in decimals. If you do all that math, you would get -3.9. Okay, so the area between -1 and 0 is going to be 0 minus -3.9, which gives you 3.9 units squared. There we go. It's that simple. If you know how to integrate using the general power rule, you know how to solve both of these questions, a definite integral and finding the exact area under a curve. This is all you need to this point to be ready for test 2. So we'll have some fun with that in a couple weeks.